In this video, we're going to go over how to multiply radical expressions or expressions involving square roots with variables and with numbers. Let's check it out. So this is really just a combination of the skills that you've already rocked in the past. So as I pointed out in an earlier video, when you have numbers that are being multiplied, what I often do is I look to simplify each individual square root first, or I look for common perfect square factors. So I'm going to continue to do that like usual, and if you haven't seen that video yet, I'd check it out. It's the one right before this one. But now when you have variables, well, those you're going to multiply together, because the variable rule, as we've seen in a previous video, is you raise, well, once you have everything to the power, that power that it's raised to, you divide by 2. So let's combine everything. I'm going to kind of split it up nicely though. So I take this, and in my mind, I'm looking at this as the square root of 9 times the square root of 6 times the square root of a times the square root of a to the 6th power. And the reason why I'm looking at it like that is multiplication is all commutative. The order in which you multiply doesn't matter. So I've got 9 times 6 times a to the 6th is multiplying all those terms. Now I'm going to deal with the numbers first. The square root of 9 is 3. So that's going to become 3. The square root of 6 has no perfect squares that go into it. So it's in simplest radical form, or it's as simplified as it can get. So now the number part is completely done for now. We'll combine everything that's outside the square root and inside the square root symbols soon. So now I'm going to multiply these two things, a times a to the 6th. Same base, same exact square root sign, so we can multiply them. We're going to add the exponents. A times a to the 6th is a to the 7th. And now I deal with the fact that I have a to the 7th. So we've got a square root of a power, so I divide 7 by 2, and that's going to give me 3 with a remainder of 1. So I end up with 3 times the square root of 6 times a cubed. That's the 3 times that, well, 2 goes into 7 evenly with a remaining amount of 1. And remember, if you need to see why that is, watch an earlier video on me taking square roots of variables. So now we'll combine everything outside of the square roots. That's 3 times a to the 3rd times root 6a. Multiply everything inside of the square roots. And that's it for that problem. Piece by piece is the name of the game, just like it was with exponents. Okay, so now here we have negative 2 root b to the 5th times 6 root b to the 7th. So here the numbers are all on the outside. So mentally what I'm doing is I'm doing negative 2 times 6 times and the square root of b to the 5th times b to the 7th. So I'm multiplying all the variable pieces together there. Okay, so negative 2 times 6 is negative 12 times the square root of b to the 12th. I get to the 12th because 5 plus 7 is 12. We have the same basis. We add the exponents. Last but not least, I've got a square root of a power. So I'm going to divide the exponent by 2. 2 goes into 12 6 times with no remainder. So we're left with negative 12 b to the 6th, that's the 12 divided by 2 with no remainder. Sweet. All right, one more problem here with multiplying radical expressions where we have variables and numbers involved. So here again, I'm going to split up everything. I'm going to do this a little more mentally. So I'm going to show and explain, but not write out every step like I did before. 4 times 2 is 8, right? So we have the numbers on the outside can be combined right away. So we have 8 times, I'm going to split up the numbers and the variables, root 15 times root 6, we'll deal with those shortly. Then you have x cubed times x to the 6th. So mentally, this is what I'm doing. I definitely reduce down the number of steps that I do, but that's what's going on in my head. So let's deal with the numbers now. We have root 15 and we have the square root of 6. Now, neither one of those has a perfect square that goes into them. However, they each have repeated factors that are going to make a nice perfect square. Let me show you what I mean. So instead of multiplying 6 times 15 and then reducing, I know that this is the same as the square root of 3 times 5 times the square root of 3 times 2. So you have the 2 3's. That's going to give you the square root of 9, those 2 3's, which is 3. So from those 2 3's comes a 3 to the outside, again, the square root of 9, and then what's remaining is 5 times 2, which is 10. Nice. A little bit of efficiency. So again, 3 times 3 is 9. The square root of that is 3. 5 times 2 is 10. There's no perfect square in there, so it stays in the square root. X cubed times x to the 6th. That's x to the 9th. We're adding the exponents there. So it's x to the 9th power. And then, as is accustomed, what we do, or as is the custom, we divide by 2 because we're taking the square root. 2 goes into 9 4 times. So we get x to the 4th with 1 remaining. And now we're just going to multiply everything on the outside of the radical signs as well as everything on the inside. 8 times 3 is 24. X to the 4th times the square root of 10 times x. And that, peeps, is a beautiful thing. That's it. They're weird looking answers for sure. But just like any problem in life, sometimes the answer is a little strange looking. If you're confident in each step as you go along and split it up into little bite-sized pieces, you'll end up with a pretty darn, sometimes weird looking dish at the end of your cooking experience. But you can be confident that it's going to taste pretty yummy. Weird analogy, right?